Yeah, so today I'm going to be focusing my talk principally on the spectrum management questions that face unmanned aircraft system communications. The unmanned aircraft systems, or UASs, consist of the vehicles, the UAVs, and where they're remotely piloted by ground stations. And the UASs have diverse fields of applications, as I'm sure we've all read, everything from supporting utilities, agriculture, construction, temporary base stations in the sky, as well as high-altitude platform stations up in the stratosphere. Ultimately, the Aerospace Industries Association expects that by the mid-2030s, there will be heavy cargo transport with UASs, as well as urban air mobility and other passenger travel. The physical and operating characteristics of UAVs, given these diverse applications, differ widely based on size, the airspace in which they operate, whether it's controlled or uncontrolled, and that's also tied into the altitudes at which they operate. Whether they're over dense urban populations or in rural areas, depending upon the application, and other considerations, including whether there are passengers. So they're unmanned, but they may have passengers. But one thing in common for all of them, they all have spectrum needs. And there's no one-size-fits-all solution for UASs, given their diverse applications and operating characteristics. The spectrum is needed not only for payload communications with the vehicles or the passengers on the vehicles, if there are passengers, but also for a variety of command and control, navigation, and surveillance as well. These challenges are being actively looked at in a variety of fora by aviation organizations, commercial wireless providers, as well as satellite operators, and standards development organizations, or SDOs, and regulators. I'm going to focus a bit of my time on UAS-C2 command and control. For small UASs, those that in the U.S. are defined to be under 55 pounds and operating below 400 feet, typically unlicensed spectrum is used not only for command and control, but payload communications as well. Some of the commercial mobile providers are also supporting these small UASs. However, the World Radio Communications Conferences in 2007 and 2012 identified two bands for UAS-C2 operations in aviation safety spectrum. And generally, these are thought to be bands that would be used for higher altitude, longer duration missions in controlled airspace. And those are the L band at 960 to 1164 and the C band at 5030 to 5091. In the United States, the RTCA, which supports the FAA in the development of aviation-related standards, issued a minimum operating performance standard that describes the characteristics needed by UAS radios, both the ground system and the UAV radios, to achieve dynamically assigned point-to-point fixed communications for UAS-C2 purposes. On the basis of that standard, in 2018, the Aerospace Industries Association filed a petition for rulemaking to develop licensing and service rules in the C-band for UAS-C2. That petition remains pending, even though the Commission has put it out for comment cycle, but they haven't initiated a rulemaking yet. Meanwhile, in parallel, the International Civil Aviation Organization, part of the United Nations, continues to develop standards and recommended practices regarding operations of C2 in this spectrum. In conjunction with the examination of this band, it's been allocated in the U.S., but service and license rules don't exist. The FAA authorization bill, reauthorization bill of 2018 requires the FCC, the FAA, and NTIA to issue a report to Congress on the use of the L and the C band that was identified by those World Radio Communications Conferences for command and control. And both the FAA and the FCC late last year, several months after the deadline in the statute, but that's a different story, they issued a request for comments separately. And those comments have come in. This Tuesday, there's a stakeholder roundtable that will be looking at the issues raised in the comments at the FAA, and the FCC will accept reply comments a week from Monday on their public notice. The record developed in response to the FAA and FCC notices is varied, as you might expect. There's a range of opinions on a variety of issues. Some of the key ones I think I've put here. Lots of questions regarding the feasibility of the L-band because of existing aviation uses. The C-band, which is more clear, the question is, should that be limited to certain mission types, long duration, high altitude, larger UAVs, or should it be available for commercial mobile operations, for example, non-aviation purposes, in addition to UAS C2? Should it be available for other aviation operations that might be compatible with UAS C2? A big question generally with regard to UAS C2 is whether commercial mobile networks infrastructure could be used to leverage the provision of UAS C2 in the C-band, or using other bands for C2 operations. So turning to that, the commercial mobile stakeholders are strong advocates for using other bands for UAS C2. And under flexible use policies, which have been used by the FCC over the past several years to license spectrum to the mobile services through auction, as long as there's no aeronautical mobile restriction, it could be used for those purposes, as long as other technical characteristics and restrictions are met. And in fact, 3GPP is currently looking at, in its IMT 2020 standards development, issues regarding UAS C2. But within the aviation community, while there's general support for the concept of using commercial mobile wireless bands for C2, they want to be sure that aviation safety is safeguarded and the aviation uses are protected if the commercial mobile wireless users are going to provide C2 operations in their existing mobile network bands. And so that's an issue as to whether they really understand the needs of aviation safety. And so more dialogue will be occurring on that front. Another key element of C2, including in the C-band that I mentioned, is satellite support. And that's particularly beyond the whatever network, whether it's commercial mobile network or a network set up specifically for UAS C2. That beyond radio line of sight type of communication is particularly well suited for satellite operators to support, both in the C-band, but also in the KU and KA bands. And in fact, the World Radio Communications Conference, which ended in late November, had several items supporting Earth stations in motion, operations from fixed satellite service operators. Those could be used for UAS C2 and other UAS communications. And the next work has several items that will try to identify additional uses of fixed satellite spectrum for NGSOs, non-geostationary orbit satellites, that again could be used for Earth stations in motion, and other protections for the control of UAS using GSO FSS satellite networks will be part of the Work 23 agenda. Turning to payload communications, typically there's no band that has been allocated for UAS payload communications. And so a little less attention has been given to this from a regulatory perspective as operators such as commercial mobile network operators are trying to develop their spectrum for the actual payload communications. And again, satellite operators as well can look at that through the same provisions that provide for the communications with the eSIMs that I mentioned earlier. One of the key questions I think we'll see develop over the next several years is whether mobile licensees will seek to remove some of the aeronautical mobile restrictions that exist in their bands to expand the potential spectrum that they could use to communicate with UASs as that industry matures. But meanwhile, the sorts of users that those restrictions are in place for, aeronautical users, passive users like radio astronomy and Earth exploration, they might re-examine mobile bands with studies of their own to see that perhaps restrictions should be put in place in bands where the use of that spectrum for UASs or aeronautical purposes by the mobile providers wasn't really contemplated. Again, the work in 2019 did look at certain U.S. payload communications in the form of high-altitude platform stations, where they expanded the spectrum, as I show here in that sub-bullet under agenda item 1.14 for global identification for HAPS. And in 2023, they'll be looking at a new agenda item for high-altitude platform stations operating as IMT base stations under 2.7 gigahertz. What I would just close with very quickly is that as the UAS industry matures, the spectrum challenges will evolve and change. So it's not going to be static even after current solutions are found. There'll be new operations in the airspace that they'll have to be compatible with, UAS communications. And also, as UAVs become more autonomous, a lot of the spectrum needs for command and control will diminish, and that may create other spectrum that could be used for UAS. So stay tuned. I appreciate your attention, and if you have any questions, I'll be around for a while.